All right, welcome to Way Cool Math School. Today we're looking at factoring this quadratic pattern. It may not look like a quadratic pattern right now, but we're gonna make it look like one in just a second. So, we're given this problem, we're asked to factor it. So, let's make it look like a quadratic. We're gonna use some substitution. We're declaring that A, I'm looking at this term, seeing that it's an x squared and that's an x to the fourth, kind of recognizing the pattern, but you'll get it over time. We're going to set it equal to x squared. Well, if A is equal to x squared, then A squared is probably going to be equal to x to the fourth. Why? Because x squared times x squared is x to the fourth. So we're ready to make our substitution. So we're going to go ahead and substitute our variable in. And now it's looking just like a quadratic. And we know how to factor quadratics. We can use the diamond method, right? So in the diamond method, we take our first and our last number. That's our A and our C. And we multiply them and it goes on the top. And on the bottom goes our B, which in this case is our negative 21. So we have to look for what can multiply to 20 but add to negative 21. Okay, give it a second to think about it. I know that 4 and 5 multiply to 20, but that's not going to add to negative 21. I know, 1 and 20, right? So if I do negative 1 and negative 20, that'll multiply to positive 20, but add to negative 21. So we can break up this quadratic into negative 20a minus 1a plus 4. These add up to our negative 21a. Right here, these two is that. And then we can factor by grouping. I can see that these first two share a 5 and an a. And I get a minus 4. And then right here, these two share a negative 1. Well, they don't really share a negative 1, but we're trying to get these to be the same. That way we can group them together. And I've noticed that if I pulled out a negative 1, that would make it the same as this. So I got 5a minus 1 times a minus 4. We've got to recontextualize this back into the original problem, which means we're going to have to set our a back. So we're going to have 5x squared minus 1 times x squared minus 4. Okay, we're most of the way there, but we also have this second factor. This is a difference of squares. Or we can say, we could diamond factor this and say negative 4 is on the top and 0 on the bottom. We're going to negative 2 and 2, and we're going to say this is x minus 2 and x times 2. And that is fully factored, at least to the extent of algebra 2. Hope you found this video useful. Let me know if you have any questions.